So cutting interfacing is like it's the process now of connecting some external memory chips, like if, for example, we have RAM and ROM, to the microprocessors, data bus, and other lines. This allows the CPU to read and write the data to the memory locations by using specific control signals and address decoding techniques to select the desired memory chips to access. So essentially, its method of establishing communication between the 8086 and external memory modules to store and retrieve data. So we have some components, no, or key points about memory interfacing, especially in this architecture in 8086. One is we have address decoding, data bus, control signals, even or odd bank addressing. We have the chip select, and etc. So let us now start, okay, this interfacing. So expected learning outcomes for this afternoon is to be able to explain how to interface memory in a microprocessor. So what is a memory unit? Is an integral part of any microcomputer system, and its primary purpose is to store programs. Okay, memory, of course, memory has always, we need to remember that if it's a memory, it is to store the programs and the data. So in memory, we have classifications or subcategories. We have the main memory or the RAM, secondary memory, we have the ROM, processor memory. So the processor memory, as what you've seen earlier, registers inside the microprocessor, store data and results temporarily, and there is no need of disparity. So for primary or main memory, which I mentioned, the RAM. So particularly in RAM, you have SRAM and DRAM. In 8086, we use primarily SRAM or the static uh, RAM. So for the primary or main memory, you have storage area which can be directly accessed by the microprocessor. Store programs and data prior to execution. Semiconductor memory using CMOS technology. And some of this we call the RAM, ROM, EEPROM, SRAM, DRAM. Secondary memory, storage media comprising of slow devices such as magnetic tapes and disks. So if you, I'm not sure if you have seen or have experienced the secondary memory, no? Before sa personal computer na ay magnetic tapes and disks na ginagamit para isulod ang atong CD or DVD. So secondary memory holds large data files and programs such as the OS, compilers, databases, and etc. So in a semiconductor memory, we have these functional blocks. Now we have input buffer, output buffer, column decoder, and row decoder. So central to this is the memory array, which has 2 to the n times the m bits. A typical semiconductor IC memory will have an N address lines and M data lines. The capacity of memory will be 2N times M bits. So the functional blocks are row address, as I mentioned, row address decoder, column address decoder, memory array, input buffer, and output buffer. The N address lines are split into Q lines and R lines such that Q plus R equals N. The Q lines are applied to the row decoder and the R lines are applied to the column decoder. So the output lines of the row and column decoder are used to form a matrix of array or matrix array of size 2 raised to Q times 2 raised to R consisting of 2 raised to N crossing points. In a semiconductor memory, the different types of semiconductor memory, we have the ROM, PROM, EPROM, SRAM, DRAM, and NVRAM. These semiconductor memories can be classified as volatile and non-volatile. So I have already mentioned this before, or I'm not sure if I did. When we say volatile memory, such as SRAM and DRAM, we have like, ano ba tawag nito? The memory or the data will be erased when a power is turned off. So for example, in our computer, sa atong RAM, no, nag-open ta og any application and the power shuts down, meaning to say that the datas or the programs that are stored, that were stored in the RAM will be erased. Okay? When we say non-volatile naman, it's the opposite. So whenever we have already downloaded something, for example, uh, and the power is turned off, no, it will be stored in a ROM, particularly, and kana si ROM is non-volatile. So meaning to say that uh, the data or the programs that were already accessed or downloaded or used or opened, no, it will be retained. Dili mawala sa imuhang memory. So that is its classification, no, of two semiconductor memories. When we talk about um, classification, no, of another, sorry, so these semiconductor memories can also be classified not just volatile and non-volatile, but also the read-only memory and the read or write memories. If you could also remember during the days, no, mga years ago, or maybe a decade ago, pag magpa-burn ta, natay ginapalit na read, rewritable, or read or write, no? So kani sila, kanang read-only memory, uh, once something has already been accessed or burned, for example, CD ato example, hindi na siya pwede mailisan because it's read-only. When we say read or write, it the files inside can be written, no, can be deleted and pwede mailisan usab, unlike sa read-only memory. So again, read-only, read or write. So let's talk about the read-only memory. ROM is a semiconductor memory which permits only a read access. It functions as a memory array whose contents, once programmed, are permanently fixed and cannot be altered by the microprocessor to which the memory is interfaced. So as I made mention earlier, so once programmed, fixed na siya, you cannot alter, no? Cannot alter whatever is inside to which the memory is interfaced. So the process of storing in ROM is called programming and provides a convenience method for classifying ROMs into one of the three categories. First one, the custom programmed or masked programmed ROM, programmable or field programmable ROM, reprogrammable or erasable programmable ROM, or the EPROM. So ROM, PROM, EPROM. Let's talk about EPROM. The EPROM is a programmable ROM now with an erasable feature. So the binary information are entered using electrical pulses and the stored information is erased using UV rays. It usually varies between 10 to 30 minutes. The EPROM is programmed by inserting the EPROM chip into the socket of a PROM programmer and providing addresses and voltage pulses at the appropriate pins of the chip. One example of an EPROM chip is the CMOS manufactured by Cypress, which is shown here on this graph. SRAM naman is a read or write memory which consists of an array of flip-flops or similar storage devices. The stored information in an SRAM is retained in the memory cell as long as power is supplied to the circuit. Each memory cell typically consists of 6 to 8 MOS transistors. So SRAMs are manufactured by multiple companies and have a common industry standard. So that is why meron tayong tinatawag na data sheets na because meron talagang standard ang multiple companies that manufactures SRAMs. So one example of an SRAM is the CMOS 6264 manufactured by Cypress.